Welcome back. In this lecture, we're going to be discussing errors and exception handling. Errors are bound to happen in your code. Nobody's perfect, and errors are definitely going to arise, especially when someone else ends up using your code in an unexpected way. We can use error handling in an attempt to plan for possible errors that may arise in our code in the future. For example, maybe in some part of your code you try to open up a file. So later on, someone else is using your code, and the user may try to actually write to the file when it was actually only opened with the mode R for reading. Currently, if there's any sort of error inside our programs, the entire script's going to stop and we get back some sort of error statement. We can actually use error handling to let the script continue with the other code and report the error. So even if there's an error, the code will report the error and continue on. Now there's three keywords for this entire process of exception handling, and it's the try, except, and finally keywords. And these are all going to have a block of code associated with them. So under the try block of code, that's the block of code that's going to be attempted, and this may or may not lead to an error. So once you try the actual try block of code, if there is an error, you have the except block. And this is a block of code that will execute in case there's any error inside of that try block. Then you have a finally block of code, which is a final block of code which is always executed whether or not there's an exception or error occurring. Let's jump to the notebook and see some examples of how to use these blocks. Okay, let's start off by actually viewing an example of some error that may occur. Let's imagine that we have a very simple function, some add function, takes in n1, n2, and then what it does, it just prints out the sum of them, n1 plus n2. You may be thinking, no problems here, I'm just going to say add 10 and 20, and you get back 30. But let's imagine you have the following situation. You have some variable, number 1, and you set that equal to 10. Then you have a bunch of code, and later on, to get the second number, you ask for it as an input. And let's say number 2 is equal to the input of please provide a number. So it asks us, please provide a number, we say 20, and then what we end up doing is we say, well, let me call that add function again on number 1 and number 2. Hopefully you realize that this is already going to give you an error, because recall that when you call the input function, 20 here is actually a string. So when I run this, it says, hey, you have a type error. So notice here that there's an actual specific exception that Python's trying to tell you about, type error. And it says unsupported operation, type S, for plus, integer, and string. It's basically telling you, hey, I can't add an integer and a string together. I can add two integers together, or I can concatenate two strings together, but I can't work with both these data types. And this is an example of the type of error you may get while running your code. And unfortunately, let's say I wanted to have a print statement. So let's say something happened, and I run this print statement is never actually going to occur. What's going to happen is I get an error, and that's the end of my script. Doesn't matter if I have hundreds of lines past this block of code, I will still get this type error, and nothing else after it is going to get executed. The idea behind the try and except and finally statements is that even if an error happens, we're going to try to do that block of code, and even if there's an error, we can continue with some more code. So how will we actually do this? Well, we have the try keyword, colon, and then we have the block of code. So this is the code that you want to try. So you want to attempt this code. However, it may have an error. So here I'm going to say result is equal to 10 plus 10. Whoops. There we go. So we know this is not going to actually induce an error. And then what I'm going to do here is I'm going to have my except block of code. So my except block of code is what I want to have happen if there is an error. And this is really common when you're building out larger libraries that other people are going to use. You can have except blocks, so you can print out a more specific message to the user. So maybe you can say, hey, it looks like you aren't adding correctly. So I'm going to run this, and notice we actually don't induce an error. Instead, I can call result here with no problem as 20, which makes sense because 10 plus 10 has no problems. Let's now actually create that error. I'm going to try to add the integer 10 to the string 10 here. Now when I run this, it says, hey, it looks like you aren't adding correctly. Now notice what happened here. The rest of the block of code was still able to execute with the except statement. My whole program wasn't shut down just because I had some sort of error like before. Instead, I tried this block of code and then I said except. And in general here, I can say except if there's any type of error, do this code right here. Now let's imagine that I want a block of code to execute if there is no exception. I could do something like this. I can say else print result, and above that I can say print add went well. So right now when I run this, it just says, hey, it looks like you aren't coding correctly. So this is known as a try except else statement. And what we have here is the block of code we're going to try, and then we have two options. If there is an error in that try block, we run the except code. Else, if there is no error there, we run this else code. So let's fix this and have it not produce an error anymore. We run this. We try this block of code. Since it was successful, we don't execute this except block of code. Instead, we jump straight to else and we say add went well, and we have 20. Okay, so let's try except else, and we can now actually use the finally keyword to have a block of code always executing, regardless if there's an error. So to show this, I'm going to build off of an example where we actually try to write some files. So let's explore this concept of try, except, and finally by working on a new example. And in this example, we're going to try to open up a file. So we'll have some test file, and we're going to start by opening it in W mode. That's write mode, which allows us to either open the file and write to it, or create the file if it doesn't already exist. And then I will say f.write, and I'm going to write a test line to this file. And then I will say except, and here I can either say except colon, and that's going to accept for any errors, but there's actually many types of errors I can specifically accept for. For example, I can try to only accept for this type error. So what happens is, notice above we had this specific type error. What I could do is say, hey, only if there's a type error, print out there was a type error. Then I could try another error that's actually associated with opening and writing files. And if you go to the documentation, you can come to errors and exceptions, and this explains syntax errors and exceptions in general, but you'll notice there's a link here to built-in exceptions, which jumps you to section 5 here of the documentation, and this is actually a list of all the different types of exceptions and errors that may happen. So if you keep calling down, there's an assertion error, there's end of file error, import errors, index errors. Some of these you may have seen before, a lot of them we haven't seen. There's OS errors, recursion errors, overflows, all different kinds of errors that you can specifically try to catch. So in our case, the error that's going to occur when you're opening and writing to files that you don't have permissions to is an OS error. And we're going to print, hey, you have an OS error. You can also say IO error, depending on what version of Python you have. And then we're going to add in a finally block. And this finally block is always going to execute no matter what. So say I always run. I'm going to run this right now. And right now we just get back I always run. So what's actually happening here? Well, we open up the test file, we call write on it. So that all works, meaning I don't have this except block running, and I don't have this except block running. So then I just say finally, I print I always run. Now let's actually induce an error by opening it with R. So that's read-only permission. So we should get an error on this line when we try to write to the file. Now we shouldn't get a type error because that's not actually the error we're getting. Instead, we should get an OS error because that's the error that's related to trying to write to a file that you only have read permissions for. So if I run this, I get back, hey, you have an OS error. And unlike last time where we had this except else, where only one of these blocks was going to run, with the finally statement, the except block will run, and then the finally block will run. And this is how you can line up a bunch of excepts to have specific things print for specific errors. What you could do is, let's say you have type error here and you didn't want to memorize all the other types. If you just say except at the end of this, this is going to be all other exceptions. So all other exceptions. And I rerun this again, and it says all other exceptions because it didn't detect the type error or any other errors that we defined. So if you just say except colon, you'll print out that error. Okay, so keep in mind, as you're beginning in Python, you probably won't memorize all the error types, and most likely your blocks of code are just going to look like this: try, except, and finally. So just to reiterate, the try block of code is the block of code you're going to try to attempt. The except block of code is going to occur when there is an error in your try statement. And then you have the option of putting a finally block here that will always run whether or not there's an error. Or you can have an else block of code that's only going to execute when there's not an error. Okay, so let's focus on this one more time here. Right now, there is going to be no error because I will say W there. If I run this, I get back I always run. So there's no error, finally block still runs. We induce an error. We say all other exceptions because I'm just saying in generally except here. It does whatever this block of code says. Finally, it does this block of code. So this finally block, regardless if there's an error, it's always going to run. So let's finish off our discussion here by showing you how to use the try except finally blocks inside of a function that tries to get a specific type of input from a user. So what we're going to do here is the following. We'll say def ask for int. So what this function does is it's going to attempt to ask the user for an integer. So we'll say the following. Try to result is equal to integer of the input. Please provide number. And then if we get an error here, I'm going to say except, and I'm going to print out, whoops, that is not a number. And then I'll say finally print end of try except finally. So I run this, and we're going to iterate on this function in just a little bit. But I'm going to call this function right now, do Shift Enter. It asks me to please provide a number. Let's give it one, 20. And I just get end of try except finally. It makes sense that whoops, that is not a number didn't print because we were successfully able to cast or transform 20 into an integer. But what happens if I run this cell again, and now I provide a word? Now I know I definitely can't transform the string's word into an integer. So when I run this, it says, whoops, that is not a number, and we get an end of try except finally. So let's see how we can now use a while loop to continually be doing this try block of code, and then except if there's an error there. Okay, so let's see if we can adjust this function so that instead of just ending after you provide the wrong word, we're going to put it inside of a while loop that keeps going over and over again until you actually have a block of code with no exception. So what I'm going to do is say while true, and you should always be careful when doing while true because it basically means you need to use a break statement somewhere to break out of this while loop. I'm going to indent all of this, so highlight it all, hit tab here, and I'll say while true, get this result as the input. Then I say except, whoops, that is not a number, and then I'm going to say continue, just to make this a little more readable as far as the logic of what's happening. Now let's say there is not a error. Then I'm going to say else, so you can actually combine else with finally here. So we're going to try this block of code. If there's an error, I'm going to say, whoops, that's not a number, continue on. Else, meaning there is no exception, that means the user did provide an integer, so I will say, yes, thank you. And now I need to break out of this while loop, so I will say here, break, which remember the break statement goes up to its enclosing loop, either while loop or for loop, and then ends it. So it will end this while true loop. Then finally, we'll say end of try except finally. Okay, so we just put these 4 blocks of code inside our while true, and we're going to break once we say yes, thank you, And we'll have a finally statement that says print end of try except finally. And we can just make it very clear that print I will always run at the end. So regardless if there's an error or not, this finally block of code is always going to run. So we're going to run this, ask for an integer. Let's provide it a correct integer. We'll say 20. Hit enter. It says, yes, thank you, end of try except finally, I will always run at the end. Let's provide it a string. We'll say Q, hit enter, and it says, whoops, that is not a number. End of try except finally, I will always run at the end. Except we have while true here, and this break hasn't actually executed yet. So we have another chance to provide it a number. We'll say Q, it says whoops again, and you can keep providing it over and over the wrong things, and it's going to keep asking you for input until you finally provide something that can actually be cast as an integer. You say 90, and it says, yes, thank you, end of try except finally, I will always run at the end. So note what's happening here. We're saying while true, try this block of code. If there's an exception, do something, and then continue. Else, meaning there is no exception, you can print some sort of statement and then break. And typically, you're only going to want to break out of this while true when there is no exception. Then finally, if for some reason you wanted something to continue, so a good thing here could be like, I'm going to ask you again, new line. So that's more a realistic example of why you would say finally. So if I run this again, it'll say, please provide a number. We give it the wrong answer. It says, whoops, that is not a number. I'm going to ask you again. Please provide number. And then you can provide it the correct number, and it says, yes, thank you. Now, unfortunately, it's going to say, I'm going to ask you again. So that's why a lot of times people don't like to mix up else and finally statements, but there's the option for you in case you want it. What you could do instead is just get rid of that finally statement and run your code like this, and you'll say, please provide number, Q, whoops, that is not a number. And you can keep doing this over and over again until you actually provide the number and it says, yes, thank you. It's up to you whether you want to mix else and finally blocks, but you can if you want to. All right, that's the basics of try except else. Coming up next, we're going to give you an assignment to test your new skills on this. We'll see you there.